Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 3.7 on graphing absolute value functions, in which we ask the essential question, how do the values a, h, and k affect the graph of the absolute value function g of x equals a times the absolute value of x minus h plus k? Oh my gosh, so much here. Okay, so we've got the a, we've got the h, and we've got the k. So basically we're transforming these like we transformed the linear functions in the previous chapter. Let's get started, shall we? Here's the first example. It has to do with graphing. We're going to do what? We're going to add to the output, and we're going to add or subtract from the input. Right? Remember, the raw x is the input, and the absolute value of x is the output in this case. Graph each function, compare each graph to the graph of f of x equals the absolute value of x. So that's our parent function, and we'll describe the domain and the range. Okay, so graphing a. So let's first graph f of x equals the absolute value of x. So that's going to look like that. Boom, right? Okay, so since in the g of x now, okay, f of x is our parent function. G of x is saying we're going to take that output, same as this, see? Absolute value of x, absolute value of x. Again, that's our output. We're going to add 3 to it. So what's that going to look like? Well, it's going to vertically translate this thing up 3 spaces. So from 0, I'm going to go up 3. 1, 2, 3. So here's my new vertex of this graph. And this point here becomes this one. This point becomes this one. This one becomes this one. And this one becomes this one. And this graph will look like, it'll look like this. Okay? So in this case, the domain is still all real numbers because it goes infinitely to the left in negative numbers, and it goes infinitely to the right in positive numbers, but the range here is going to be what? Now my lowest value here is at 3, so the range here is going to be y is greater than or equal to 3. Okay, let's take a look at b here. So the parent function here will also look like the one in the original graph, which is like this. Okay, but now what's happening here? We're modifying the input, and remember, whenever we do anything with the input, everything is backwards. So it looks like it's minus 2, but what we're really going to do is translate this horizontally 2 spaces to the right. So this vertex 1, 2 becomes over here. This point here at 1, 1 becomes 1, 3. This point here at 2, 2 becomes 2, 4. This point here at negative 1, 1 becomes negative 1, positive 1, and so on. So this graph will look like this. This is a horizontal translation 2 units to the right. Now I didn't write these down. I didn't write this down on this one. This is a vertical translation 3 units up. This is a horizontal translation 2 units to the right. And as far as domain and range goes, domain and range remain unchanged. Domain is still all real numbers. And the range is still y is greater than or equal to 0. We didn't affect the range because we're translating horizontally. Okay, let's take a look at the next example. Example 2, reflections in the x-axis and y-axis. Graph each function and compare it to f of x equals the absolute value of x. All right, describe the domain and range. All right, so let's take a look here first of all. Well, I'll put the parent function back up here again. Okay, so those are the parent functions here. Even though this is reflections in the x and y axis, it should probably say something more like stretching, shrinking, and reflecting, because we're going to be maybe doing those things. All right. So in this case, what's happening? In this case, we are multiplying the output. This is the output again. This is the output, the parent function, by 2. Right? We're multiplying it by 2. So this is going to be a vertical stretch. By a factor of 2. Okay, so what's that going to look like? Well, we're going to take all of our y values and multiply them by 2. So what's that going to look like? Well, here the y value is 0. 0 times 2 is 2. Here the y value is 1, right? 1 here and here. 1 times 2 is 2. So that one goes here and this one goes here. I'm moving it up, right? I'm moving it up. Here the y value is 2, and here the y value is 2, and 2 times 2 is 4. So it's going to go up here and here. So this graph will look like this. Okay, so we call this a vertical stretch. You know, think of it, you know, as like when you take something that's kind of short and round and you stretch it, it gets like longer and skinnier. I don't know, maybe that's a visual that might help you. I don't know, these words don't exactly match the way we think of things, so it gets kind of hard. Okay, so what's happening in example B over here, we're multiplying the output, so it's going to be a reflection over the x-axis, and we're multiplying by 1/2, so it's going to be a vertical shrink by a factor of 1/2. So what's that going to look like? Well, we know that the reflection is going to be this way, right? So let's do this. Let's shrink it first, and then we'll reflect it. Okay, so if this y value is at 1, down here, then if I multiply by 1/2, it'll go through here and here. If this y value is at 2, here and here, 2 times 1/2 is 1, so it's going to go through here and here. And if this one's at 4, this y value is at 4, half of 4 is 2. So it looks something like that. And I'll put that in for us to kind of look at before we actually do the reflection. Okay, so I put that as a dashed yellow line. It's kind of like the temporary line. So then we're going to reflect this over the x-axis now. So if this is at +1, this will be positive 1/2. I've got negative 1/2 here and here. Positive 1 becomes negative 1 here and here. And positive 2 becomes negative 2 here and here. So the final graph will look like this. Right? So this is a vertical shrink. So, you know, it's shrunk. So, you know, it's I don't know how to describe this. If you think of these things as heights, now we're shrinking it, so now it's like lower, and then we flipped it over the x-axis. So that's what that one looks like. Okay, let's move on to the next one. Okay, well, I didn't write this down, but again, horizontal reflection over the x-axis and a vertical shrink by a factor of 1/2. All right, let's move on to the next one. This form of an absolute value function where we can see a horizontal translation and a vertical translation, that tells us that the vertex of that absolute value graph, remember it kind of has that V shape, the vertex of it, the corner of it, is going to be at point HK. Remember, but this is this is a minus, so it's going to be, it kind of looks like the opposite of this. Right? So HK. And that is kind of, it also says any absolute value can be written in this form, and its graph is symmetric around the line x equals h. So that vertex point kind of splits the absolute value vertically. Well, let's take a look at this here. Okay, so this one is a little bit different because look at this one. Graph f of x equals the absolute value of x plus 2 minus 3 and g of x equals 2 times x plus 2 minus 3. Compare the graph of g to the graph of f. Okay, so first off, we have to see what is different between these two. And it's this. We're multiplying the input by a 2. And everything that happens with the input is reverse of what we think it should be. So this is going to be a horizontal shrink by a factor of 1/2. That's the answer to this. It's a horizontal shrink by a factor of 1/2. So let's go ahead and graph this now. This one is unaffected by that, but I have this vertex here of plus 2, minus 3. Remember, this is minus -2. Because the vertex form, it's minus, right? It's minus here. So I have to think this is minus -2. So I have a vertex at -2, -3. And then I can graph that in as that, right? So now, what's the difference here? Now I'm going to have a horizontal shrink by a factor of 1/2. And what's that going to look like? It means that all of my x values are going to be multiplied by 1/2. So let's see if we can take this graph and do that with it. This first one's going to be easy because I'm at -2, and -2 times 1/2 is -1. So my new vertex is going to be here. Okay, and so that one goes this way. Let's see. I've got -5. So that's going to be, what, -2.5? Right there. And then I've got 1, so half of 1 is 1/2. So right there, let's see, I'm at 4 here, so this should be, half of 4 should be 2. Okay. So this graph should look like this. This is what a horizontal shrink, horizontal shrink, sorry about that, horizontal shrink by a factor of 1/2. This is an A. This looks like a star. Horizontal shrink by a factor of 1/2. That's what our graph should look like. Okay, so there's example 3. And tell you what, this video is going on 13 minutes now, so we'll save example 4 for the classroom. All right. Thanks a lot and have a great rest of your day. Bye-bye.